So it would be easy to explain to you pure functions in an abstract way, but I'm going to show you where they actually matter in your Swift code, and spoiler, that's in testing. But I hope this also helps you get a grip of what pure functions are. So here I'm going to use tests to talk you through pure and not pure functions. And the clue here is when I run these tests, and it's in the playground and the code is in the link below, not all of them pass. And it's an indication that not all of these are pure functions. So the first one happens to be a pure function. It's not reliant on global state and there's no side effects. And yes, I could have written the return keyword there. I could have done this without string interpolation. But basically all it's doing is writing hello world with the name. And I've got two tests for it with two different names. And it doesn't matter which order I have these tests. It doesn't matter if I had another 100 tests with different names. They're all going to still pass because this function's pure. It's not reliant on the global state, for example, where the order might matter. Which brings me on to this second example. With the counter, it's taking this counter and incrementing it by a number, then returning the counter. But it's relying on this counter property, which is outside the function. And what happens is, I want to add 1 to the counter, and when it's initially 0, it will be 1. And the second one, if I increment the counter by 2, which is initially 0, I'd expect it to be 2. But I know this test is going to fail and come up with 3. But the problem is, if I make it 3, it's reliant on running after this test. And if another developer comes along and say, doesn't run that test, then we're going to get another failure. So it's not really the test that's failing, because this test becomes dependent upon the test just before it, so there's the failure. This test is dependent on the one before it for its result. And not only dependent, it's dependent on the order which you run the tests in. So this is a problem when functions are not pure. And here's another example. So it's kind of a special case where you're testing random here. You give it a number and then you come up with a random number between that, which I'm going to test 4 and 100. And when I run it, what's going to happen is it going to equal 35, and it might do by chance because it's going between 4 and I think it just said 100, and I think it clearly goes up to 99, but still 8's not equal. And if I make this 8, it's highly unlikely to come up with the same answer again because it's dependent on random. And the solution for this is probably to inject a random function in when you're testing it, and using int.random when you're in production. But that sounds like a kind of dependency injection type video for another day. So this is a special case of a not pure function. This function's not pure because it's mutating this, we'll call it global state. And this function is pure because it can just run, and you can have many tests and not dependent on each other, they're not dependent on the state. And you want to be in that place where you can test your functions and where they are pure. So I hope that's useful to you, because all of your functions that you test should be pure. That means isolated, that means not affecting each other and not affecting global state. Well, that's the end of this video, and if you want to like and subscribe, go on to Madonna's videos and do that to her.